can unmute and speak. Maybe Vamsi Krishna, you may unmute and speak. Am I audible? I hope I am audible. Uh, Maybe someone from you can unmute and speak to me. Are you able to listen to me?
Yes, sir, your voice is audible, sir.
Okay, thank you, Chakravarti. Thank you very much. I will proceed with sharing my screen. So we are into end effectors already. Maybe few contents under this we have already seen. Maybe some slides I will try to go at a faster pace. End effector is nothing but a device that has been attached to the wrist. Maybe that can be viewed as an attachment for the wrist. Okay, that is how a general purpose robo is going to be converted to rather to perform a specific task. If you want, you can replace those end effectors in order to vary, in order to handle the different types of specific tasks. And of course, sometimes it has been referred as robo's hand. And minimum task when you try to refer, it is supposed to provide sufficient grip. It should be in a position to pick the objects. It should be in a position to place the objects, releasing the objects. And of course, any special task, if it has been assigned to it, it should be in a position to handle that. So those are some of the tasks that are all being given, and they have been classified into two categories. One is grippers, another one is EOAT, end of arm tooling. And of course, when you try to refer the name gripper, name itself is trying to give you some hint on that, the functioning of it, because it is actually housing grip word in it. So gripper as an end effector, it is supposed to grasp an object and it should hold that particular object properly. Without our knowledge, we are using our hand to use mouse, handling the glasses, and so many objects we are trying to do. Okay, so depending upon the type of object you are trying to handle, pressure you are going to apply between the fingers is going to be sure vary. That we can sense. On the similar grounds, the grippers, whatever you are trying to use, but depending upon the object you are trying to handle, you are supposed to move them, and the certain related, rather relative amount of efforts or force or torque need to be applied onto them. And of course, various locations where and all these grippers are going to be used have been shown. Of course, without this, the robot cannot do any task. Like something like our human body, not having hand, we will not be in a position to do anything. Only with the support of this hand, we are in a position to do many things. Maybe writing, eating, and giving some signals, showing some expressions. Okay. So likewise here, some power portions of applications have been showed like loading and unloading, picking parts from a conveyor, arranging parts onto a pallet. Not only that, handling cartoon boxes, bottles, raw materials, and tools, etc. Okay. Then, if you try to see the types of grippers, maybe you are having a list over here. We shall try to see to the maximum possible extent at least few sketches out of these six varieties. and wherever possible, where maybe from the source, open source, to the possible extent, I have tried my level best to get some GIF files, and those things have been made as a part of my presentation. Okay, so altogether, these grippers should be designed such that they should be made versatile and flexible. They should be made versatile and flexible. So that flexibility and in order to make more versatile and flexible, the gripper should be designed such that it should have all the features, like it should be in a position to orient, it should properly provide sufficient grip, because all the processes it is trying to handle is actually the manner in which our hand is trying to see. We are able to orient our hand in spite of this being attached to the wrist. It is not being located at the same place. Whatever the way you want, you are able to orient. And all five fingers are there. Unlike your robo gripper, we have got five fingers. All these five fingers are so flexible that you can grasp whichever the object you want. To the possible extent, you are going to provide sufficient grip to it. Whenever you want to pick, your hand is going to on to that, and that is going to pick with sufficient grip. Whenever you want to place it in a particular position, you are going to move it to that location, and you are going to release it. Suppose if you try to take up some different types of grippers, maybe end tools, welding, I hope you would have been given some kind of demo on welding trade. Looking at that particular welding spark itself, you need sufficient practice. You should have, your body should tune to that. Otherwise, if that particular smoke gets into your eyes for that particular night will swell and will create so much of difficulty. So welding, it appears when somebody is doing is so simple, unless otherwise you get exposed and experience it, it's not going to be. That too, you'll have to move your hand, maintaining same gap between the body or pieces you are trying to weld and the space you are trying to maintain over there. Simultaneously, that welding rod will be what you call spending its flux. It's going to deplete. Slowly, its length is going to reduce when you are continuing your welding. Means while moving, your hand also should make horizontal movement and vertical movement simultaneously. I am trying to give you the complexity associated with the welding. Even that can be made possible with this particular robot. When you want to maintain uniform welding, when you want to maintain quality of welding, all that, you need to resort to only robo automation. Okay. Anyway, even that is going to become as an attachment to your wrist. Few things out of them have been showed, and those welding and all will come under UAT. Okay. Now you can see fingers sometimes called jaws make actual contact with the object. Some simple things. Normally in the applications for robot, two fingers are only going to be there. You see here, some critical mechanism have been accommodated over here. You will go to this particular complexity when you want to move, provide motion to the greater extent and with greater accuracy. Otherwise, what happens is maybe in the next slide I may show some other kind of motion for your end effector. For your end effector, I may show some other kind of motion wherein there will be some sliding action. Here, different links are there, and with the support of those links, those jaws are moving. Those jaws have been used to pick up an object. Those jaws have been used to pick up an object. Okay, same jaws here. See, this is one part of mechanism. This is another part of mechanism. This is getting swiveled over here. Okay, so it is ensuring that these jaws are always perpendicular. That too, they have been moved by small extent always. Okay, so in majority of the cases, we try to come across only two fingers, and getting three or more than that are very, very uncommon situations. Okay. And it is something that you see a mechanical hand that wraps around an object will rely on friction in order to secure the object when it is holding. See here, this material is actually something. Internally, you have got red color, maybe some kind of rubber kind of material is going to be there. See, our skin, here it is not so smooth. If it is so smooth, whatever you try to handle, you cannot handle. You cannot keep it with all what you call tightness with which you wanted to. You can test. You apply some oil and you try to hold something. There ends your business. So means whenever there is some friction, that time for the gripper, okay, for the fingers in this particular case, only then the object what you want to pick, you will be able to. Only then the object what you want to hold properly, you will be in a position to. Okay. Since these are all simple points, I am not trying to read out or going through all the points. Some points which are all silent, they have been highlighted in this particular slide. Friction is an important point. Say mechanical grippers is being continued. Friction between the gripper and the object is a major point, and that friction is majorly depending on two aspects: metal, metal on metal, and rubber on metal. See, fingers may be metal, and the object you are trying to handle may be metal. Fingers may be metal, object you are handling may be rubber. Fingers may be having rubber line, object you are handling may be metal. And of course, obviously the surface may be having some smoothness or it might even have some rough surface. All these things matter when you are trying to show the accountability on the grounds of friction. Okay. Second one is actually the force that you are trying to apply. Means the fingers are going to be brought closer. More and more you bring close, the object which has been kept in between, that is going to be applied pressure. See, this is the paperweight. Now it has been just held. If I want, I can apply small pressure and I can leave it. But if some obstruction comes, the friction that is available between this particular paperweight and my hand or the fingers, that might not be sufficient to hold it properly. Then what we do is we will try to apply some more, we will try to move those fingers a bit close. Then when you try to move those fingers a bit close towards the object, more force you are going to apply. So what amount of force you need to apply, that you should quantify. You should know. I cannot apply the same force whatever I am using it per year again for this. I cannot apply force whatever I am using it here to pick up this for this. Because if I apply my same more force, see, it is actually going bending. And more force if I apply, this may even break out. So force that is going to be applied majorly depends on the object you are trying to handle. Now, mechanical grippers are more often fitted with some type of pads, as you are seeing in this particular sketch. Metal outside, internally it is having a pad. That padding is actually normally made from polyurethane. That is one kind of material. Okay, polyurethane that will be having some kind of flexibility, some cushioning action will also be there. On along with the friction, rise in the quantity of friction, we will be able to have some cushioning action. Okay, so once you go for that, the damage that might cause because of the pads on the workpiece can be eliminated. Moreover, since there is appropriate friction between because of the presence of polyurethane as a pad material for your finger, there will be sufficient grip. Friction matters a lot for having sufficient quantity of grip. And of course, the grippers whatever you are trying to use, They are going to be designed for a particular purpose. And of course, when you are trying to design to pick up a paper weight of this particular size, say, there is a flexibility that you can accommodate. Sizes there for various sizes of this particular shaped objects. If you want to handle, you can provide such a flexibility into them. That is possible. Okay. So though you have tried to design your mechanical gripper which suits, which serves for a particular purpose, but keeping in an object of size of that particular object, say similar kind of objects, maybe if you have some variations in sizes, it is quite possible for us to extend that particular design to handle. Then sometimes you can even have dual grippers, like you are having two hands. Means for the same end effector, there will be two grippers. Means two objects at a time you can pick them up. Two objects at a time you can manage. Two machines can be loaded. Two activities at two different locations can be managed by having, rather by employing dual grippers. Of course, it's all depending upon the work environment within which you are trying to use your robo. Your environment also should support to take the support of dual grippers. How does it matter? That is going to show its impact directly on productivity. It is something like you are being computer science people. I can give you a simple example which will reach you very easily. Say in front of me there is a keyboard. In front of majority of you also there is keyboard. Majority of us are habituated to use single finger to key in the data. We are all tuned to use single finger to key in the data. In your experience, you would have seen people using both the hands, putting 4 and 4, 8 fingers on the screen, on the, what you call, this keyboard, and those fingers will be moving forward and backward, and without looking at the keyboard, they will be very comfortable to key in the data whatever they want. See the flexibility. Who knows typing, they will be able to use all these 8 fingers. Why 8 fingers? All these 8 fingers, all the 8 fingers you are trying to use in such a manner that whichever the key nearer to a particular finger, that is going to be used to operate that particular key button. That is how you are able to minimize the time you are going to take to key in your programming code. So that is how the data what you can enter into your system can be improved. Okay, rate of entering that particular coding can be increased. That in production aspects, when you try to say that productivity is going to be increased. Okay. Anyway, gripper mechanism is to translate some form of power into grasping actions. Say, gripper, what it is trying to do, it is trying to put something, pick up something. But how it is doing, it is actually getting some power on the input. And that input is actually being converted to what form? Grasping an object or releasing an object and providing sufficient movement to the fingers. This is what. See, whatever is happening with our physical senses, maybe whatever you are visualizing for a human hand, and your robo might not be having so much of flexibility, but almost all same operations are getting done with the support of a robo hand and its end effectors or its fingers. So that is why when you are trying to go through these statements, you should recall those statements also, and you should visualize these movements. Then it will be easy for you to. And what are the various power inputs that are going to be supplied to these clippers? It could be pneumatic, it could be electric, or it could even be hydraulic. The mechanism must be able to open and close the fingers, and it should be in a position to exert sufficient pressure or force against the part when they were brought close to hold the object securely. So it is trying to handle this particular glass. Once it has been instructed to pick it up and place, or some other kind of target being given, it should be handled properly. This is being a glass, maybe this might cost you about 50 rupees or 100 rupees, or maybe more than that. Why might not use? If that is dealing with a cell phone, if that is dealing with some costly object, so the object, whatever it has been handled by the robot, that should be held properly. The force, the required force, whatever you are trying to, that should be appropriate. That again depends on the variety of object you are trying to handle. See, the force applied on the object, how much it should be? It should be sufficient enough with respect to the friction such that it should retain the part. So how much, rather, how to quantify that? That quantification has been given here. Because when you are trying to move, that is going to be moved against gravity. And when you are trying to move, that is going to be moved with a particular acceleration. There may be some other force. One particular force, I can give you an idea that self weight of that, or some other force, some other load might be acting on that. So any additional force that are all playing at that instance, all that should be kept in mind when the time of you are trying to quantify the force with which you are trying to pick it up. It is not simply moving your fingers by, say, for example, this is actually of diameter 10 centimeters. You might write a code to move it by 10 centimeters, and it might not be picking it up. You know that the diameter of this is 10. You know that you have moved it by 10, but it might not be providing sufficient grip, sufficient force. It would have not got applied. Okay, so we may have to quantify that particular force with the respect of displacement. With the support of sensors, we should be in a position to measure that. Anyway, some of the grippers have been showed here. Say this is your gripper being attached to the wrist. You have got finger here and finger here. Since you are trying to handle a circular object, the shape of this particular finger pad being attached to that is going to be on par with the shape of the work part. Okay, say something like this. You are trying to handle this glass. Shape of the pad is going to be something like this. If it is like this, what is going to happen? You are going to have line contact. Okay, area what is trying to maintain contact is not going to be good. Whereas if you put it like this, then you can see all these fingers. You can see all this entire hand surface area is trying to maintain contact. You will get better grip. And force, whatever you are trying to apply, will be transferred to the entire area with which it is trying to maintain contact. Okay, now if you want, you can detachable type of gripper. See, in one instance, you might need to use this type of finger. In the other instance, you might need to use this type of finger. And same thing, maybe in some of the situations, it would have been visualized like this, so that in order to make these two grippers fingers to move, you can see this linkage. This is one link, this is another link. If you make this particular link to move up or down, accordingly, those fingers will come forward and backward. So when you want to pick up an object, you are going to operate this entire linkage, and you will ensure that those pads are going to come close to that. Whenever you want to release the object, you are going to again operate that particular linkage, and you will ensure that those pads are going to move backward. And those pads, you may assume that they are going to be only in circular in fashion. No, not at all. You can see flat type, and in again flat type, this is fixed, and here it is hinged. Hinged in the sense, you will have the flexibility. Say, suppose if I hinge it at this end, you will have flexibility to have some motion for this. Once you fix it here, you cannot move. Whereas if you hinge it here, about this, you can move it. That is the advantage over here. Okay? If you fix it up, the object should be kept parallel to that perfectly. Whereas here, even if the object is at some oriented inclination, accordingly, these hinges can adjust and pick it up. Now, this is actually V block, same V block with hinge model, and circular, this is fixed, this is with hinge model. And I am not trying to segregate only to the mechanical. I can tell you that these are all different types of grippers that have been collected from through online source. You can see here there is a screw for which some threaded portions are there. If you rotate the screw, see, that rotation can be made either in the clockwise direction or anti-clockwise direction. Accordingly, these rollers will move. That will make the, what you call, your entire fingers to move downward and forward. Okay. So something like that. On the similar grounds, out of these fingers, if you try to observe, this is actually belly type. Means if you supply pressurize there, some portion will extend and it will try to hold that. Say, for example, say there is a glass like this. You try to blow balloon, keep the empty balloon in it, and you go on blowing air. What happens? Balloon goes on expanding internally. So when you blow it sufficiently, the pressure whatever you have blown into the balloon, that will try to go and expand, and it will try to hold that particular glass. That is the kind of technique being applied over here. Internal expansion gripper. This is external. This is the object being held here. That is why this has become internal expansion. Now here this is the object you wanted to hold. So in that case, pressurized air you are going to supply to the balloons or to the expansion kind of material externally, and that is going to expand. It will expand and hold that. Okay, so this is how you can go through these things. This is actually pertaining to the magnet kind. You can see this is actually what you call magnet not for non-permanent. These are actually permanent magnets, and these are actually cup type. Maybe you would have seen some plastic thing hangers onto a smooth surface. When you press, airlock occurs and it will try to stick. And whenever you want to remove, you can slightly raise it up, and air tries to get in through that, and it will try to come out. That technique has been used to pick up some lightweight objects. So we are not going to stop our images being showed. We will see at some other appropriate linkages. And that particular slide was given a broad idea on few varieties of the what you call grippers or end effectors. Anyway, various types of actuating mechanisms are used in mechanical grippers, and of course they have been not shown below. They have been shown in the earlier slide. I'm sorry. I'll make a note that correction. So slide number 12, first statement below should be changed. Actuation of fingers. You have seen many things. See, you can see this. This is the linkage. This link is actually something. And if you see this, these two are the fingers. This is the linkage. Here, these two are the fingers. This is the linkage. And here, what is happening? Those fingers are opening and then closing. See here, this is the linkage, and these two are the fingers. Likewise, when you go through these sketches, all the fingers are getting activated by different means of linkages. That's what it has been stated over here. So some of them have been listed out. It may be through linkage, it might be through screw, it might be through gear and rack, it might be through rope and pulley, it might even be through cam actuation. These are all mechanical terminologies. Out of my interest, I am trying to show you if situation comes, you'll have to use this particular content on the day of examination. So this particular one is actually giving the actuator. This actuator is moving forward and backward. If this moves forward, what happens? Okay, this is going to push. This link is there. This link is going to move outward. Even this will move outward. Once this moves outward, since this has been hinged, these two fingers will move forward. Say close. And if you move this actuator backward, then this is going to come down. Then this will pull this, means these two hinges will move towards inside. Then since this has been hinged here, it is going to open. Ends of the fingers are going to be open. So these are all various things. They have been showed here not with an idea of making you to draw everything on the day of examination. You should get an idea that there are various kinds of linkage mechanisms. We call them as kinematic linkages. For a particular purpose, see, you have got moving upwards. This is got moving inwards. See, though this is moving inwards, but their forces that are going to be applied are not in the vertical direction. They are going to be perpendicular to these fingers. So this is how the purposes are going to be totally different. Only to give you a clarity on that, that has been. Now if you try to see this, I may not be able to show you exactly rack and pinion. I thought I have copied some other sketch. We'll show you, I'll take you to that particular location. It is something like, suppose you have a wheel like this, a straight wheel wherein a straight rod wherein tooth will be here. There will be another gear tooth for which tooths are there. Suppose if I move forward and backward, what is happening? Observe this rod horizontal member. I am moving forward and backward. There are no tooth, but there you are going to have tooth. That is actually making these particular wheels to rotate either in the clockwise direction or in the anti-clockwise direction. That you should understand. Okay, so that is actually contributing towards the motion of this. Let us see this. See here, see, you have got gear wheels here. Okay, you have got, see, when the rod has been moved backward and forward, you have got teeth rod, and this particular teeth rod is actually maintaining contact with these rotary rather gear wheels. And here, if you observe, this is actually the best example what you can visualize when you are steering your car with the support of rack and pinion arrangement only. Front wheels are actually moving forward, either taking left turn or right turn. The importance of rack and pinion arrangement has been clearly explained with an example what has been shown applied normally in cars. And even in these two cases, you can visualize that that is actually trying to provide, say when you move this down, these gear wheels are going to rotate like this, and that is going to contribute towards the inward motion of the fingers or outward motion of the fingers. Okay, so you see, you can see this. This is the rod having horizontal bar having teeth, and this is your gear wheel. If I move this particular one forward and backward accordingly, this particular gear wheel is going to rotate either clockwise or anti-clockwise. And of course, here same sketches I am going to use for cam operation also. Here, this is the teeth member, vertical teeth member. These are the teeth which are having gear wheels. When I move this upward and downwards, these gear wheels are going to rotate. Accordingly, these two wheels are going to rotate. Accordingly, these two fingers will move forward and backward. Okay. So you need to understand. Okay, I'm sorry. Uh, I came out of this. I don't know whether I am okay. I'm still in the class. That's good for me. Thank you. So why I am trying to give you so many examples are you need to understand, and when you want to understand, maybe when you look at one sketch, when you have asked me to write draw something on board, I may hardly confine myself to write only one sketch. Since I am trying to hardly copy and paste, I've got flexibility to show many varieties of images. Somehow the animation part is actually not working. Cam actuation. This particular slot you can see here, and this particular bolt has been attached to this particular slot. When you rotate this particular wheel, since this bolt is actually made to follow this particular slot, when this bolt is following automatically, this has been connected to these two bars, and automatically that bolt is going to move and that is going to operate this. Somehow it is not showing the animation. The reason, let me not bother. Let me take time to reload and show you in some other classes. Maybe the best example what I can tell you is in your bikes there are going to be two valves. One is inlet, another one is outlet. And those valves are going to be operated by some push rod. And sometimes that is going to be operated by means of a cam. In the next class, I will bring some example, some working model I can bring and I will show you for cam. So cam in the sense, maybe normally it will be something like this. You will be having a rotary member. You will be having a rotary member. On that there will be some projection like this. When you rotate this, suppose if I have a follower like this, when I rotate like this, say when this follower is maintaining contact up to this, okay, once this comes to this particular portion, what happens? This is going to rise. Follower is going to rise. That is how the cam is going to take the support of, cam is going to make some other link to activate. Okay. So the examples, whatever I have showed you earlier, similar kind of examples I can show you. Okay. I'm sorry. You can see here, this is the cam you are having. Now here that model is working. You can see here. This is the cam here. Say if I move forward, this cam is going to rotate these things. Simultaneously, the distance between these two is going to be increased. So depending upon the direction you are trying to move, the distance between these two rollers will either be increased or lowered. Since there is a spring here, whenever you are trying to move it back, that spring pushes those rollers towards, close to them. Because of this particular hinge, when this has been moved up, this will move down. When this has been moved down, this will move up. Same thing here. See, this is the cam here. And here, these two are the cams. Here, this is the cam. Here, these two are the cams. Okay. So, depending upon your requirement, you should be in a position to devise these mechanisms. Only to give you an idea that there will be no single point type of what you call end effector. Depending upon your requirement, depending upon, say here, since you have put straight line, movement is going to be linear. Since you have put the curved portion, the movement is going to be non-linear. Okay, so it's all varies. Okay, let me stop at this point. I thought I can complete this, but somehow I'm sorry I could not complete. At least by tomorrow, I will try to close down. Okay, so let me stop my presentation.